Hi, this is David Voss, CCIE 11372, and in this video we will be going over VLANs. Now, I don't want to assume that you know what VLANs are, so part of it is just an introduction to VLANs. Then we'll talk about VLAN switch port types and VLAN membership for those switch ports, VLAN numbers and ranges, and then we'll talk a little bit about VLAN trunks because it's an appropriate conversation to have, although there is another video that's going to be dedicated solely to VLAN trunking. Then we will talk about VLANs and network addressing, and then finally implementing VLANs on a network. All of these you will need to know to pass your CCNP switch exam. So what exactly is a VLAN? Well, Cisco says it's a group of end stations with a common set of requirements. Using VLANs allows you to put many different devices in many different locations on the same logical network, on the same layer 2 network. In the past, without VLANs, you would have had to rely upon simple hardware solutions, but a VLAN allows you to virtualize your layer 2 segment. VLANs are usually associated by the same subnet, so normally devices on a VLAN are sharing the same subnet. And with this in mind, they're sharing the same broadcast domain. That is the norm. And then VLANs must be routed to communicate with other VLANs. So it is a true layer 2 segment. A VLAN is not going to be able to communicate with another VLAN unless it is passed through a layer 3 device which can route it. Now, there are two types of switch port types for VLAN membership that we need to understand. And the first is the access port. Now, access ports can only belong to a single VLAN. Now, when you think of an access port, it's pretty much probably what you think of. It's usually for end devices like a workstation or a server. It is a device that is an end station. And again, access port can only belong to a single VLAN, typically used to connect end devices. And there are two methods to assign ports to VLANs for these access ports. The first, which is by far the most popular, is the static VLAN assignment. So an administrator actually doing it, and then dynamic VLAN assignment, which is done by a server. So let's dig a little bit more into those two concepts. So when we have a static VLAN assignment, the network administrator is actually manually configuring a switch port to be a part of a VLAN. The network administrator is programming the port to say, you are going to be an access port and you're going to be associated with this specific VLAN. Now, you can do this dynamically, and this is not as popular, but there is something called a VLAN management policy server, which can assign a desired VLAN to users connecting to a switch. We don't need to get much deeper than that for your exam, but you do need to know these two methods. Now, there's another type of port that we need to understand the concept of VLANs, and that is trunk ports. And trunk ports are used to carry data from multiple VLANs. So access ports only allow communication from one end device over a specific VLAN. Well, ultimately, if you're hosting many VLANs, this traffic is going to need to be able to communicate throughout your network so that they're not limited by a hardware device. So your VLANs may be spread throughout many floors or maybe even many buildings. Trunk ports allow you to carry data from all these different VLANs between all your different hardware devices. Now, there are some standard VLAN numbers and ranges you should know. Specifically, let's focus on 2 to 1001. These VLANs are created and used and deleted on all Cisco Catalyst switches. And another one that you should really focus in on is the range of 1006 to 4094. These are extended. This is an extended range of VLANs for Ethernet VLANs only. Now, you may be asked about these other ranges, but I would focus in on VLAN ranges 2 to 1001 and 1006 to 4094. Now, we talked a little bit about VLAN trunks earlier, but let's just hit upon VLAN trunks a little bit more so we can understand it. Now, again, I want to remind you that there is another video that is dedicated solely to VLAN trunks, but let's just get a basic understanding here. VLAN trunks are used to carry data from multiple VLANs, which you already know. Now, there are two methods, two protocols that can be used to build these trunks. And the first is Inter-Switch Link, or ISL. And that's a Cisco proprietary protocol that is used to preserve the source VLAN identification information for frames that traverse trunk links. And then there is, I would say, the more popular 802.1q, which is an open standard. And then it performs a little bit differently than the Cisco proprietary protocol. Now, the reason 802.1q is so popular is you probably understand that for obvious reasons, that if you want a trunk between two devices, one is Cisco and one is non-Cisco, you're able to do that. So this standard works very effectively, and 802.1q is very popular. But you will definitely be asked about ISL, and you will definitely be asked about the differences between ISL and 802.1q. Now, so you've received a lot of information right now. So let's go ahead and kind of draw out some of these concepts that we've been talking about. So when we think of VLANs, we think first of we need to connect, endpoints need to connect on a local area network. So here we have 4 endpoints, and we have one switch. And each of these endpoints need to communicate, and not all of them need to communicate with each other. So let's say we have 2 workstations and 2 servers, and we're going to put this one workstation in VLAN 10 and this other workstation in VLAN 10, and then these 2 servers in VLAN 2. These 2 servers are segmented on their own VLAN, and as are the workstations. They cannot communicate between each other, between VLAN 2 and 10, but anything on VLAN 10 can communicate with VLAN 10. Now here's another dedicated VLAN, we'll say VLAN 3, to a dedicated device. Now, and here is a router. So for any of these VLANs to communicate with one another, they need to pass through a layer 3 device. So this workstation that from VLAN 10, if it wants to communicate over to a server, it needs to be routed and go through the router and passed over to VLAN 2. Let's say you want to keep VLAN 3 devices not accessible from the network. You can prevent that. So here we have other devices on VLAN 3, and we'll say, let's say this is a back-end connection between 2 servers that we have no need to route it. VLAN 3 can be segmented from the entire network. Nobody can reach it. So there's some security built into VLANs as well. Now VLANs can extend obviously over to other hardware platforms. So this router is connected to another switch, and on this switch, let's say that's in a different building, we have another device on VLAN 2, another device, another endpoint on an access port to VLAN 10. And if they want to communicate over to the other building, let's say VLAN 2 or VLAN 10, they simply go over this trunk port, you know that term, goes over the trunk port and can communicate over to the other sites. Configuring a VLAN is rather straightforward. You simply go into configuration mode and type in VLAN. And for the sake of this example, we're assigning it number 10. And then normally you would name the VLAN so anybody logging in would understand what that VLAN, what the purpose of the VLAN actually is. So the purpose of this VLAN is actually to host servers. You can name it obviously anything you want, but in this case we'll just say servers. And then you have the VLAN built, but you still need to assign ports to that VLAN. So you assign a port to a VLAN by actually going into interface configuration mode. And in this example, it's Fast Ethernet 02. And then you need to make the Ethernet port an access port. Now remember, those 2 port types that we're concerned about, access port and trunk port, we're making this an access port. And then you enter in the command switch port access VLAN in the VLAN you want it to participate in. And let's say on Fast Ethernet 02 we have a server we're connecting, so we're going to assign it to VLAN 10. And that is it. That is it. So let's tell you what, now that we've talked about how to configure it, let's go ahead and go into the lab and actually configure it. And obviously it's pretty straightforward, but nothing beats actually logging in and just doing it yourself. So, and we can take a look at actually what it looks like when we show some of the information for the VLANs we're configuring. So here we are on a switch. And again, we go into configuration mode, config T. And we simply type VLAN. Now there's many options here, but we're just worried right now about assigning a VLAN to it. So we're going to create VLAN 10. And let's go ahead and name it. And we're going to name this VLAN 10 servers. And let's go ahead and create another VLAN 20. And we'll name that workstations. So let's take a look at what our configuration is. So we simply do show VLAN. And there you will see we have a VLAN 10 and we've created a VLAN 20, servers and workstation. Now notice there's no ports assigned to these. You will see if we scroll up a little bit that by default on this switch, VLAN 1 is already created and the ports are assigned to VLAN 1. Well, we want some of those ports to be assigned to VLAN 10 and 20 because we're going to be connecting some servers and workstations to this switch. So we go into interface configuration mode and we're going to go into Fast Ethernet 02. And we want Fast Ethernet 02 to participate. We want to make it an access port, so switch port mode access, and then we want to assign it to VLAN 10. Switch port access VLAN 10, and there you have it. Now on port 3, let's assign it to VLAN 20. And obviously we can do more than just one port per VLAN, so let's go ahead and assign port 4 to VLAN 10 and port 5 to VLAN 20. And there you have it. Now if we show our VLAN configuration, you will now see that ports 2 and 4 are assigned to VLAN 10, ports 3 and 5 are assigned to VLAN 20. Fairly straightforward. Now again, they will not communicate between one another, between VLAN 10 and 20, unless they are routed between each other. But that being said, you've created 2 broadcast domains. So here's what you've learned. You've learned about VLAN switch port types and VLAN membership. You've learned about VLAN numbers and ranges, VLAN trunks, VLANs and network addressing, and finally implementing VLANs. You've done it in the lab. And I think you have a really good foundation on moving forward. And good luck in your studies. Thank you very much. Hi, this is David Voss, CCIE 11372, and in this video we are going to be learning about trunking. We're going to go over a basic trunking overview to start, and then we'll talk about trunking protocols, ISL and 802.1q. And then we're going to configure and verify some trunk links, and then we're going to talk a little bit about DISL and DTP. And then finally, we will not only talk about, but also do this in the lab. We'll be filtering VLANs over the trunk links that we create. The primary purpose of trunking is to carry traffic between switches and to maintain the VLAN information. It's not like an access link though, because a trunk link does not belong to a single VLAN, but instead carries traffic from several VLANs over a point-to-point link. So for example, if you have a port on VLAN 10 in one part of your network, And then let's say on a different floor, connected to a different switch, you have another endpoint connected to VLAN 10. VLAN 10 information would be advertised over a trunk link between these two switches so that communications could occur. Now there are two key protocols you need to understand for the development of VLAN trunks. First is ISL, which is Inter-Switch Link. It's Cisco proprietary. And what it does is it preserves the source of VLAN information for frames that traverse the trunk links. And then there's 802.1q, which is the IEEE standard. And what this does, it inserts a single 4-byte tag into the original frame. Now, understand that there are many differences between ISL and 802.1q, but just for now, understand that ISL is the Cisco proprietary protocol, 802.1q is the IEEE standard. Let's go ahead and expand upon this concept of trunking. So think of any neighborhood or small neighborhood in a suburb, and there you will see many driveways which generally support just one car at a time. So let's just draw these driveways, each supporting one car. Now, the cars ultimately need to leave the driveway, and they do so by getting on a street where all the cars share the road. So they go from a driveway where it just supports one single car to a street that supports multiple cars, each car trying to get to its destination. And there are certain rules in place so that everything works correctly and everybody goes the right way safely. Well, trunking really works the same way. Think of these as access ports, or driveways as access ports on a switch, where a single VLAN is supported. And think of the major streets as your trunk link, where traffic from multiple different access points or different VLANs traverse the trunk link. So let's draw this concept out further regarding trunk links. You have endpoints or nodes on your network. We'll draw these out, and they each connect to switches. And let's say we have here's a telephone. Endpoints could be a laptop. Endpoints could be a server. They all connect to switches, and they would do so, let's say, via VLAN 10 and VLAN 20. And let's say over here for the phone, he's a participant in a dedicated VLAN 15. They can all access the network through their access ports. But if we need to communicate via the switches, we need these VLANs to pass over these trunk links. So one trunk allows VLAN 10, 20, and 15 to traverse this trunk link. If we add a new VLAN 30, we either could or could not allow it to traverse the trunk link. If there's VLANs in other areas of our enterprise, let's say VLAN 10 and 20 and VLAN 15 are scattered throughout, obviously the trunk links are going to be needed in order for traffic to pass over our network. So as you can see on the trunk links that we're configuring, we configure the VLANs that are allowed over a trunk link that are only needed. So on this example with this switch, we just need 10 and 30 to traverse that trunk link. Between these other two switches, we just need VLANs 10 and 20 and 15 to traverse the other trunk link. Now ISL operates in a point-to-point environment, and it can support up to 1,000 VLANs. The original frame is encapsulated, and an additional header is added before the frame is carried over the trunk link. And then at the receiving end, that header is then removed and the frame is forwarded to the assigned VLAN. Now there's some other things about ISL that you should know, such as the support for PVST and then the ISL frame information. This is information that will be beneficial for your test. Now, 802.1q, as I said earlier, is much more popular, mainly because it's an open standard. So it inserts a single 4-byte tag into the original frame, and then the trunking device recalculates the frame check sequence before it sends the frame over the trunk link. 802.1q also has a user priority field. Now, if you've worked at all with telephony, this would look familiar to you. The 3-bit field, it refers to the 802.1p priority, and there's 8 separate levels of priority. And then it also has a VLAN identifier field, and this is a 12-bit field that uniquely identifies the VLAN to which the frame belongs. Now, to configure and verify a trunk link, it's actually rather straightforward. To configure it, you simply go to the interface that you would like to create as a trunk link, and you type in the switch port command, and then you type in switch port trunk encapsulation, and you choose which encapsulation you would like to use. So you can use .1q or specify .1q or ISL, or you can have it negotiate. And then finally you create your trunk, so switch port mode trunk. And that is it. And to verify, you simply type in show interfaces and then the interface that you configured, and then switch port afterwards. Now, Cisco offers dynamic trunking protocols. DISL and DTP help switches automatically negotiate whether to enable a common link as a trunk or not. Now, as the name indicates, DISL supported ISL only. So even though the software was included on all Cisco switches, once 802.1q was offered, Cisco needed to upgrade the protocol. So when 802.1q was introduced, the protocol needed to negotiate whether to use ISL or 802.1q encapsulation. Therefore, Cisco introduced the second generation trunk negotiation protocol, which is DTP. Now, with DTP, if the switch port is in a dynamic desirable state, the port will actively attempt to become a trunk if the neighboring switch is set to desirable or auto. But if the switch port is set to auto, it is passive, and the port will only become a trunk if the neighboring switch is set to dynamic desirable. So let's jump on switch ALS1 and let's configure a trunk between ALS1 and ALS2 over Fast Ethernet 011. So as you remember, we jump on the interface itself, Fast Ethernet 011, switch port mode dynamic to use DTP. Let's set this side to auto, which is a passive state. It's not going to initiate DTP packets. And then on ALS2, let's do the same thing. Let's actually set it to dynamic auto, which people often do, unfortunately. But this side is also now in a passive state. This trunk's not going to come up because both sides of the trunk are passive. You can see, even though we've programmed it correctly, this trunk is not going to come up because this side is set to a passive state of auto. And as you can see on ALS2, you don't see a Fast Ethernet 011 trunk. Even though we've programmed trunking for that interface, it's not showing up. And it's not going to show up until that trunk establishes. So what we need to do on Fast Ethernet 011, at least on one side of this trunk, is change it from auto to desirable. So on ALS2, what we'll do is we'll get back on under Fast Ethernet 011. Let's go ahead and change it from dynamic auto to dynamic desirable so we can initiate some DTP packets and thus bring the trunk link up. And you'll see once we set it to desirable, you'll see this trunk link come up. And there we see Fast Ethernet 011 show up in the trunking table. And it is up and functioning. So here's how you filter VLANs over a trunk. Specifically, use the switch port trunk allowed VLAN command. For example, if you want to specify that VLAN 1, 10, and 20 may traverse the trunk link, you program switch port trunk allowed VLAN 1, 10, 20. If you want to specify that all VLANs may traverse a trunk link except VLANs 10 through 30, for example 10, 11, 12, then you would program switch port trunk allowed VLAN except 10 through 30. And then finally, if you want to specify that VLANs 1, 10, and 20 are no longer allowed to traverse the trunk link, that is, you want to remove them from what you already have programmed, you can do that by typing switch port trunk allowed VLAN remove 1, 10, and 20. These are just 3 examples. There's many options you can use, but these are just 3 examples of how you program filtering of VLANs over a trunk link. Let's go ahead and filter some VLANs over our trunk link. So let's jump on to ALS2. And again, we'll go under Fast Ethernet 011, use that trunk link. Let's take a look at it. You can see that we are allowing all VLANs. Now let's go ahead and begin to filter what VLANs are allowed over this trunk link. So let's go back under Fast Ethernet 011 and let's just allow VLAN 10 and 20 to traverse the trunk link. So we simply type in switch port trunk allowed VLAN 10 and 20, and now you will see the only VLANs that are allowed, the only trunking VLANs allowed are VLANs 10 and 20. Now let's say we want to remove one of these VLANs. You don't have to reprogram everything. You can simply remove one of the VLANs manually. Let's go back under Fast Ethernet 011. And this time, let's just simply type remove 10. We're just going to remove VLAN 10. Now, VLAN 20 will be the only one showing as allowed over the trunk link, as you can see here. And now let's say we want to add a VLAN over this trunk link without having to reprogram it again from scratch, because oftentimes you can have many VLANs and you don't want to have to redo everything. So we just type in switch port trunk allowed VLAN, and then we type in add the VLANs we want to add. So we'll just say we want to add 30. So now when we check, we will see that the trunk link is allowing VLAN 10, or excuse me, VLAN 20 and VLAN 30. So here's what you've learned in this video. You've received a trunking overview, and you've learned about the differences, the basic differences between ISL and 802.1q. You've learned about how to configure and verify trunk links, and how Cisco's proprietary dynamic trunking protocol can help bring up trunks automatically. And finally, you've learned how to filter VLANs over trunk links. All of this information you're definitely going to need to know to do well on your CCNP switch exam, and I'm confident you will do well. Good luck in your studies, and thank you very much. Hi, this is David Voss, CCIE 11372, and in this video we're going to be talking about the VLAN Trunk Protocol, or VTP. So here's what you're going to learn. We'll be doing a VTP overview, then talk about VTP Domains, Modes, Advertisements, Passwords, Versions, and Pruning. So let's get started. So a quick VTP overview. This is a Cisco proprietary Layer 2 messaging protocol which manages the addition, deletion, and renaming of VLANs on switches in the VTP domain. It allows VLAN information to propagate throughout the switched network. So this is critical if you want to reduce administrative overhead in a switched network. It enables switches to exchange and maintain consistent VLAN information without requiring consistent manual intervention. Now, a VTP domain is basically a group of adjacent connected switches that are part of the same VTP management domain. So note that a switch can only belong to one VTP domain at one time, and it will reject or drop any VTP packets received from switches in any other VTP domains. So if you set a domain on a switch, it will participate in VTP advertisements for that domain. But again, it will reject any VTP advertisements from other domains. Now, here's a real critical concept for you to understand in VTP. And actually, it's very important to make sure your network stays up and running, because often there can be confusion about what these modes, VTP modes, actually do. So not only is this important for your CCNP switch exam, but it's also important for you as you administer your network. The VTP server mode is a default VTP mode for all Cisco Catalyst switches. On a VTP server, you can control VLAN creation, modification, and deletion for the respective VTP domain. What happens is that it stores the VLAN database in RAM, and then it advertises this VTP information to all other switches within the VTP domain. You will see in the lab the effect of programming a server has throughout the VTP domain. Now, each VTP domain must have at least one single VTP server switch. Consider this your administrative switch. Now, the next mode we want to talk about is client mode. In client mode, the switch can advertise and receive VTP information, but it does not allow VLAN creation, modification, or deletion, and it cannot modify or store the VTP database in NVRAM, but it can receive VLAN information, but only from the VTP server switches within the same VTP domain. Now, finally, there's transparent mode, which allows for the creation, modification, and deletion of VLANs, but note this is critical to know about transparent mode. This is only locally significant. So the creation, modification, and deletion of VLANs is only locally significant, and this information is not propagated to other switches in the VTP domain. It passes VTP updates, but it ignores them as far as applying them to the local database. So VTP advertisements are sent out periodically by each switch in the VTP domain via its trunk link. And it should be noted the important configuration revision number. Switches use a configuration revision number to keep track of the most recent information in the VTP domain. This is incremented every time new information is received. The switch with the highest configuration revision number is considered the switch with the most up-to-date information. So this should bring out some red flags for you if you're adding a new switch to the network. If you add a new switch to the network, and let's say this switch has been previously configured or used somewhere else, if it has a more recent configuration revision number and you insert it into your network, the information on that switch will propagate throughout the VTP domain, and all the other switches will revert to that configuration. So you need to make sure when you're adding a new switch to your network, you understand not only what VTP mode it's in, but also what VTP domain it's in, and finally, what configuration revision number it's set at. Well, let's draw this out so we can understand the concept a little bit better. Now this server is going to connect into a client, and let's say we program on this VTP server a VLAN 20. That information is passed over to the client, and the client will learn about that VLAN 20 automatically. Now if that client will then pass that information on to the other switch. Let's say we have another client as well, and that client will also insert VLAN 20 into its VLAN database. Now let's say we have a switch in transparent mode. we will pass VLAN 20 onto this switch. It will not insert it into its local database, but it will pass that information on to the other client for insertion into its database. Now, the one in transparent mode, let's say he adds VLAN 17 and 18. Again, these VLANs 17, 18, and 19 are only locally significant, and this information will not be passed on to any other switches. So it can participate in the domain and pass advertisements, but the VLAN you create on a transparent switch will only be locally significant. So if we add VLAN 20, 30, and 40 on the server, and you log on to the client, you will see VLAN 20, 30, and 40 on any client participating in that VTP domain. So let's go ahead and test this out in a lab. So we're going to jump on switch ALS1, and you can see here we have VLAN 10, 20, and 30 on this switch, already programmed, supporting desktop, servers, and marketing. And now on DLS1, let's take a look, and you'll see that we don't see any of those VLANs. This is because we really don't have VTP up and running at this time. So back on ALS1, we're going to set it to VTP server mode. And we do this by VTP mode and then server. And I believe it already is a server, but now you know how to program VTP mode for server. So ALS1 is going to be our VTP server. ALS2 is going to be a client, so VTP mode client. And now on DLS1, we'll make that a client as well. And on DLS2, we're going to make this a transparent VTP mode transparent. Now back on ALS1, let's take a look at VTP status just to verify. Yes, here we are. We are a VTP server. But you notice there's no domain name set. Now on ALS2, let's take a look at our status. And we are, in fact, a client. But notice the domain name is already set. So even though he's a client, he will not receive VTP advertisements from the server. Now on DLS1, take a look at status. This is also a client with no domain name set. And finally, DLS2, verifying our status. This is in transparent mode. Now on ALS1, let's go ahead and configure the VTP domain for CCNP. And you'll see here on ALS2, the domain name is mycom. We're going to switch that to CCNP. On DLS1, we're going to switch it to CCNP. And on DLS2, we're going to switch it as well to CCNP. So now they are all participating in the same VTP domain. And now the advertisements will begin to flow between these switches. We show the VTP status. It is a server on ALS1. It is in CCNP domain. On ALS2, the number of VLANs is now matching that of ALS1. Total VLANs 8, whereas before we had 26. So as you can see, it's been overridden, and now our VLAN database matches that of ALS1. On DLS1, we also see the number of existing VLANs is 8, whereas before it was different. And then on DLS2, we can see our existing VLANs is 10, it doesn't match 8. Why? Because it's transparent. It's only going to pass advertisements. It's not going to insert it into the local database. So if we look here on ALS1, again, here are VLANs 10, 20, and 30. Let's just focus on those for now. And DLS1, VLANs 10, 20, and 30. And finally, DLS2, which is transparent, we will not see VLANs 10, 20, and 30. Again, transparent is not going to insert the VLANs into the local VLAN database, although it will pass the advertisement. Now on DLS2, let's change it from transparent to client. And once we do that, you will see the VLAN advertisements for 10, 20, and 30 show up. And there we have it. So there's a basic understanding of VTP in our switched lab. On your CCNP switch exam, you may be asked about the different VTP versions. This is what I think you should know. VTP version 2 offers the following enhancements over VTP version 1. Version 2 offers token ring support, unrecognized type length value support, version dependent transparent mode, and consistency checks. Version 3 offers the following enhancements over version 2, which is enhanced authentication, support for extended range VLANs, private VLAN support, support for any database in a domain, and it offers VTP primary and secondary servers. Now let's move on to VTP pruning. VTP pruning is rather important because it increases network available bandwidth. And it does so by restricting flooded traffic to trunk links that the traffic must use to reach the destination devices. So in other words, it blocks unneeded flooding of traffic to VLANs on trunk ports that are included in the pruning eligible list. Now this is disabled by default. You need to enable VTP pruning for that to work correctly. Now please note you can only enable VTP pruning on a switch in VTP server mode. You do that simply by going to global configuration and entering VTP pruning. So here's what we've covered. We've gone over VTP, just a general overview, but then we got into the specifics of VTP domains, modes, and advertisements. And then we talked about versions and how version 3 has enhanced the authentication over version 2 so you can use passwords. And finally, we discussed VTP pruning. I'm confident you will need to know all of this to pass your CCNP switch exam, and I'm also confident you're going to do well. Thank you very much and good luck in your studies.